So, number 12. Actually, I posted the answer key on Classroom, didn't I?
You did.
Yeah.
Pull up that and check it that way, and then we'll go over what we need to. That would make much more sense. Alright, looking at problem number 12. We have to write the equation for the tangent line on part A. So to write the equation of a line, you need a point and a slope. Now the point, I told you, was 1 f of 1. F of 1 meaning to get your y value, if you plug a 1 into your equation, we get 3 plus 4 minus 5, so we get 2. So our point is 1, 2. Now we need a slope. Slope of the tangent line comes from the derivative. So if we do our derivative, this is just a polynomial, so nice pretty derivative. We get 6x plus 4. Then what do I need to do with that? Plug in the 1. I need my derivative when x is 1. So I get 6 plus 4, which is 10. So now we have a point and a slope. So we can write our full equation. Plug into y equals mx plus b. So your y-intercept is negative 8. Final equation would be y equals 10x minus 8. You guys didn't ask about b, but I know there were a lot of questions yesterday. What is a normal line? Perpendicular to the tangent line. So this line has a slope of 10. So on part B, you would want the slope of the line perpendicular, which would be negative 1/10. And then you used your same point and slope to write your equation. Alright. 13b. So I'm asking you to do the definition of derivative here. So, what is the definition of a derivative? We might have a problem if nobody can tell me. Alex?
F of A minus F of A plus H. All of which.
Right. We had like 2 different versions that we could use. We preferred to do the one where we did the limit as h approaches 0, because then our denominator was just h instead of a minus h. So we're going to do the limit as h approaches 0. And then when we evaluate our function, we do f of x plus h. So your function was x squared plus 5 on top, right? This was the big, or no, we're on part B. So our function was x plus 1 over x minus 1. So x plus h plus 1 over x plus h minus 1 minus f of x. So x plus 1 over x minus 1 all over h. I will probably ask you to do one definition of derivative question on your final. Okay? So far, so good? Now we have to start cleaning this mess up. I know a lot of you were looking at my answer key and asked me how I did what I did. So I wanted to get rid of the fraction within a fraction. So I said, well, if I'm going to cancel this first denominator, I would have to multiply by x plus h minus 1. But you can't change your problem. So if you multiply it by it on the top, you have to do the same thing on the bottom. To cancel this one, we need an x minus 1. So I multiplied by x minus 1 on top and bottom as well. Alright, so then when you take this times your first term, what happens? The denominator cancels. So I've got the limit as h approaches 0. I'm left with my x plus h plus 1 times just the x minus 1, because the other part canceled out. Minus, in this term the x minus 1 cancels, so you have the x plus 1 times the x plus h minus 1. On the bottom, we have h times all of that. Oops, that's a minus right there. Okay. Now we have to start simplifying. So I need to multiply all this stuff out. So that gives me x squared minus x plus xh minus h plus x minus 1 minus x squared plus xh minus x plus x plus h minus 1 over the denominator. Because of the minus, you need to distribute a negative. And then we're going to start seeing what cancels out. So my negative x and positive x would drop. Same thing over here. I have x squared and a negative x squared, so that cancels. I have xh and negative xh, that cancels. Negative 1 and positive 1 cancels. So on the top I'm left with a negative 2h over the denominator. So, I need a new sheet of paper. What's going to happen here? I can drop out an h, which leaves me with the limit as h approaches 0 of negative 2 over x plus h minus 1 times x minus 1. Now the deal is we can plug in as long as we're not getting 0 on the bottom. At this point, I'm no longer getting 0 on the bottom. So this is the step where I quit writing my limit. You better have it written on every step until then. So if I plug a 0 in for this h, I just get an x minus 1. Here's an x minus 1. So you could put negative 2 over x minus 1 squared. Okay, so be able to do a definition of derivative completely. Now, we've done them like on part A, it was a polynomial. The nice thing about those, you can work them out the other way we've done derivatives to check yourself. You know, I could have done the quotient rule on this problem to confirm that this is the right answer as well. But I will expect you to do a full definition for one problem on the final. Are we okay with that one? So problem 14. This one is asking us about velocity. So I have my position. Okay, I want the location when the velocity is 0. So if you have position, how do you get velocity? The first derivative. What is the second derivative? Acceleration. Good. So that would give me a 32t minus 80. And I want the position when the velocity is 0. So if you set that equal to 0, divide by 32, and you get 2.5, or 5 over 2. So basically, this tells me after 2.5 seconds my velocity is 0. But have I answered the question yet? No, I didn't ask when the velocity is 0. I said what's the position. So I have to take this and plug it into my position equation. Okay, why would I have gotten a negative value here? What does that tell me? How can a position be negative? Yeah, it means you went backwards. 101, I didn't even give you units on this. Feet, yards, whatever we were measuring in. Okay, second thing I asked for was average velocity from 1 to 4 seconds. We've talked about two different types of velocities, average and instantaneous. Instantaneous was when we made the tables and looked at what value it was approaching. It's like the slope of the tangent line. Average is just a slope between 2 points. It's like a secant line. So I gave you two different times, 1 and 4. We need to find our y values and then calculate the slope between those for the average velocity. So if you plug a 1 into which equation will I put that into? The first one. So if you put in a 1, you get negative 65. And when you put in a 4, what do we get? What did you get? Positive 65. So now we do the slope between those. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I get 130 over 3, which you could leave it as that fraction if you'd like.
It's negative.
I was going to say, that doesn't match the answer on my key.
It's
Okay, so this should be a negative 65, which gives you a 0 on top. So we get a 0 for our answer. How could you have an average velocity of 0 if we know it was moving the entire time? What's that telling me? Yeah, it's saying it went forward for a while and it went backward, because velocity can be positive or negative, shows direction. So essentially it's stopped where it started. Okay, number 15. Alright, so we have h of z equals z times the square root of 25 minus z. And we're asked to find h double prime of 4, so second derivative here. Can I plug in the 4 now? No, not until the very end. I would rewrite this as square root as like a 1/2 power. Okay, so this one is going to get ugly, isn't it? You guys ready? So first derivative. What do we have to do here? Product rule. We have two things being multiplied, so product rule. So derivative of the first will be 1 times the second plus the first, so z, derivative of the second, so the exponent comes down, inside stays the same, subtract 1 from the power, we have to do the chain rule, derivative of the inside is negative 1. Okay, if I clean that up, we get 25 minus z to the 1/2 This would be a negative 1/2 z times 25 minus z to the negative 1/2. So that's our first derivative. Now let's do the second. So derivative of this term, exponent comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, which is a negative 1. Alright, I'm going to, instead of putting this minus here, I'm going to go ahead and write this as plus a negative 1/2. That way we don't fail to distribute a negative later on. So we're going to do product rule again here. We have these two, this times this. So derivative of the first, derivative of negative 1/2 z would be negative 1/2 times the second plus the first derivative of the second. So the exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Okay, we can clean this up a bit. What do you guys notice about these? They're like terms, aren't they? They both have a 25 minus z to the negative 1/2. So I can add their coefficients. This would be a negative 1/2 plus a negative 1/2 is just negative 1. Okay, this one, a negative 1/2 times a negative 1/2 times a negative 1 will give me a negative 1/4. Okay, so that is my actual second derivative. That's h double prime, but I need h double prime of 4. So if I plug in a 4, this gives me a negative 25 minus 4 would be 21 to the negative 1/2. So that's like 1 over the square root of 21. The negative puts it on the bottom, the 1/2 makes it a square root. Minus 1/4 times 4, 21 to the negative 3/2. So that would be 1 over the square root of 21 cubed. Okay, so I cleaned mine up quite a bit. Um, 1/4 times 4 cancels. Square root of 21 cubed, so if you have 3 of those, you could pull out 1 and leave you with 1 underneath. Technically, I did a couple things. I think I put mine together with common denominator and got the radical off the bottom. That's how I got to my answer. If I needed a common denominator, what do I have to take the first one times? 21. So if you add like terms, that gives me a negative 22 over 21 radical 21. And then the final step I did is I got the radical off the bottom. So on the bottom, 21 times 21 is 441. So definitely an ugly problem. Probably wouldn't give you one quite that ugly, maybe with quite so many radicals, or I might not ask you to simplify it entirely on the final. But it is all stuff that we've done before. So find that second derivative and then plug in your value. Questions there? Alright, 16. We've got a few of these we want to talk about. So first is F. I'm just asking you to find the derivative here. So our function is g of t equals the square root of 1 over 3t to the 5th. First thing I would do is definitely write that as a 1/2 power. Then there are several ways you could begin this problem. You could do the top to the 1/2 and the bottom to the 1/2 and rewrite it like that. You could keep it this way. You could do 1 times the bottom to the negative 1/2 power. So any of those work. I don't remember which way I did it on my key. I think I rewrote it as a negative. You guys okay with that? Because it's just 1 over, we can just bring that bottom up. But when you change floors, it changes the exponent to a negative. So this is probably the simplest way to go about it, but not the only way. We could get there using the quotient rule and the chain rule. So now we have to do our chain rule. So exponent comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, which would be a 15t to the 4th. Okay, clean that up just a little bit. A lot of times I didn't make you simplify your derivatives entirely, but we can at the very least multiply our coefficients here. So if I take the negative 1/2 times 15, so negative 15 over 2, t to the 4th, times 3t to the 5th, to the negative 3/2. I left my answer like that. You could have changed it if you wanted to drop that 3t to the 5th back down to the denominator and make a big fraction. Did anybody go that far? Okay, so I'm going to leave my answer like this. Next we have h. So that one was a trig function. Okay, what you have to remember is when you see a cosine squared x, that means the cosine of x to the 2nd power. Sine cubed x means the sine of x to the 3rd. So what I have is really a product rule. I have this times this. So, working through my product rule then. Derivative of the first. So that means the exponent will come down. Inside stays the same. Subtract 1 from the power, so now it's to the 1st. Times the derivative of the inside. What's the derivative of cosine? Negative sine. Okay, all of this is just representing the derivative of the first one. But we still have to take it times the 2nd. Plus the first. Derivative of the 2nd. So the 3 comes down. Inside stays the same. Subtract 1 from the power times the derivative of the inside. Derivative of sine is cosine. Okay, from here, we can do a few things. The negative, I'm going to pull it out in front and make that a -2. I have a cosine. I have a sine times a sine cubed, so that would be sine to the 4th. Okay, over here, I'm going to pull my 3 out. I have a sine squared, and I end up with cosine to the 3rd if I put those together. You could factor out greatest common factors and things, but this is the form I left my answer in. So that is all we have to do. Is that on my right place? Okay. There are a couple different approaches for this problem. And we can keep it like this. We could also write it as the top and bottom each to the 5/3 power, if you want to distribute that. Did you guys separate it, or did you just work like this? From here? Okay. So we have to do chain rule. Exponent comes down. Inside stays the same. Subtract 1 from the power. Times derivative of the inside. So to do the derivative of this inside, it is a fraction, so we have to do the quotient rule. So low, 1 plus x squared. D high, what is the derivative of e to a power? E to the power. Minus high. D low, derivative of the bottom. So derivative of 1 plus x squared would be over low squared. Okay, from here we could clean this up quite a bit. I'm going to just rewrite this a little bit. I'm going to take my 2/3 to the top and bottom. So e to the x to the 2/3 is e to the 2/3 x. On the bottom, I'm going to write that as 1 plus x squared to the 2/3. In this fraction, what do those two terms have in common? So we could factor out an e to the x. That leaves us with a 1 plus an x squared minus a 2x. Okay. So now let's just write this as one big fraction. So the top, we have a 5. E to the 2/3 x times e to the x. When you multiply, you add those exponents. So 2/3 x plus 1x would be e to the 5/3 x. I have my 1 plus x squared minus 2x. On the bottom, we have a 3. We have a 1 plus x squared to the 2/3 and to the 2nd. So if you add those, you get 8/3. Again, this is a problem where there are several ways you might have your answer written. This looking is where I stopped on my answer key. Questions there? Okay, 18b. So we are doing implicit differentiation. So the idea is most of the time when we are doing a derivative, we have y equals something with an x in it, right? And this y, when we take the derivative, we change it to a y prime or maybe a dy dx, and we do our derivative. In this problem, is it possible to just get y equals? No. So in this case, we go ahead and we do the derivative like normal, but every time we do the derivative of a y, we put dy dx with it, and then we'll solve for that dy dx later. So basically, this is too complicated to solve for y, but the derivative might be able to solve. So we're going to do the product rule. Okay, so the first times the second. So derivative of the first, derivative of x to the fourth would be 4x cubed times the second plus the first, so x to the fourth, derivative of the second. So derivative of x plus y. Derivative of x is 1 plus, what is the derivative of y? Dy dx. You could call it y prime. I just usually don't because I find that prime marks are easily lost in your equations. So I like the dy dx. Over here, product rule again. So derivative of y squared would be a 2y, but I did the derivative of a y, so it gets a dy dx, times the second, plus the first, so that's my y squared, derivative of the second. So derivative of 3x would be 3, minus derivative of y is dy dx. Okay, our goal here is to solve for dy dx. So let's start multiplying things out. If I distribute, we get 4x to the fourth plus 4x cubed y. Here we get x to the fourth plus x to the fourth dy dx. Over here we get 6xy dy dx minus 2y squared dy dx plus 3y squared minus y squared dy dx. Alright, pretty ugly right now. We have 1, 2, 3, 4 things with a dy dx in it. So what am I going to do with those? We want all of those on one side and everything without it on the other. So I'm just going to bring my x to the fourth over, and I'll take this 3y squared over here. I do have a few like terms we can combine in the process as well. 4x to the fourth and 1x to the fourth will give me a 5x to the fourth. Plus my 4x cubed y. Subtract over my 3y squared. Okay, over here I have my 6xy dy dx. Negative 2y squared and negative y squared will give me a negative 3y squared dy dx. And we subtracted over the x to the fourth dy dx. Okay, so everything over here has a dy dx. What do you do? Okay, if we pull out that dy dx, then it's multiplied with this thing, so we can divide it over. So dy dx is 5x to the fourth plus 4x cubed y minus 3y squared over 6xy minus 3y squared minus x to the fourth. I didn't, but what if I asked for a second derivative? What would you do? Yeah, you would do the derivative from here, so you'd end up doing the quotient rule. And you would still put dy dx every time you did the derivative of a y. And then what would you do with those dy dx's? You'd plug this in for them. So I'm not even going to attempt that right here to use it as an example because this is really ugly. I would definitely give you a much nicer one if I asked for that. Okay. We've got like 8 minutes. Are there others? Anything else on the study guide? The entire study guide? Any question that I haven't answered yet that you would like for me to work at? I'm sure there's something. Let me give you guys a problem then. I want everybody to work it. Figured we could use another trig function practice problem. Yes, you have to do a product because we have this x cubed times the tangent of 3x to the fourth. Okay, does that mean you have like tangent to the fourth power? No, that fourth is just on the x. Okay. So product rule, derivative of the first. So derivative of x cubed would be 3x squared times the second plus the first, so x cubed. Derivative of the second. Okay, you have to know your derivatives of trig functions. What's the derivative of tangent? The angle stays the same. But we have to do the chain rule here. So derivative of the inside, derivative of 3x to the fourth. Okay. I'd like you to clean it up just a little bit. So x cubed and 12x cubed gives us 12x to the 6th secant squared 3x to the 4th. Okay, so let's run through our derivatives of the trig functions. Derivative of sine, cosine. Derivative of cosine, negative sine. All the cos, remember, have a negative derivative. Derivative of tangent is, and derivative of cotangent, negative cosecant squared. Derivative of secant, secant x, tangent x. Derivative of cosecant, negative cosecant x, cotangent x. Okay. I only have like a minute and a half, so I don't have time to work any more problems. Tomorrow, we're just doing general review, so make sure you look back over that study guide, and if there's anything specific that you want more practice with, make some notes so I know what we need to go over. Alex, would you turn the light back on, please? Thank you.